L'Hopital's rule involves limits, but the reason we can't cover it in the limits unit is because you need derivatives in order to do it. Don't close the computer. So we have to cover derivatives before we can do L'Hopital's rule. So we're going to circle back to limits for just a minute. The two indeterminate forms that we're going to do are 0 over 0 or infinity over infinity. Those are the ones that are fair game for you. But just so that you know, in case you go on to like do higher level degree of mathematics, like in college or something, there are a whole lot of indeterminate forms, like 0 to the infinity power, and infinity times infinity, and infinity to the 0 power. Do you know what I'm saying? Interesting world out there. We're going to do these two. Okay? So here's your L'Hopital's rule. If f of x and g of x are differentiable, can I abbreviate differentiable and you'll all know what it means? Okay, because I don't want to abbreviate to the point that you don't know what I'm talking about anymore. Okay. So if those functions are differentiable, then limit as x approaches c, and again, when we do a problem, c will be a number, okay, of f of x over g of x equals the limit as x approaches c of what? I'm going to throw it out there because you guys seemed to know this. F prime of x over g prime of x. Now listen, because I'm going to have to do a little pep talk here. And I don't like this, but I'm the messenger. I'm just going to let you know how it is. Okay? If it is a multiple choice question, you will simply do the problem. Take the derivatives and plug it in, you're done if it's multiple choice. If it is free response, which they have put one of these on the free response every year for like the past couple of years. So it's likely they like this problem because they're mean about it. The people who write the test are mean, all right? I don't know, I'm the messenger. Okay, but I'm going to tell you how it is. There are a lot of things you have to write in order to get all the points. So I'm going to do one problem full. We're going to write out everything you would have to do on the free response. The rest of them, we're going to just do the problem, okay? Okay. So when you see this, you're going to have to do limit as x approaches 1 of just the numerator, and you're going to have to do limit as x approaches 1 of just the denominator. You have to do them separately. Here's the reason why. If you plug in 1 to each of those, what are you going to get?
0 over 0.
And here's the thing. 0 over 0 is not a number. It is an indeterminate form. And you can't say that something equals an indeterminate form. So you have to do them separately. So this is usually worth 3 points, okay? It's usually a point for showing each of those limits, okay? You get a point for showing each of those limits. Cool so far? It's not hard, it's just writing, so you just can't be lazy, all right? So this tells you, oh, I'm allowed to do L'Hopital's rule, because it has to be one of these forms, all right? So now we're going to link these two things together. The second point is for linking them. So you must recopy the problem. It's cool, I kind of just wrote all that. Yeah, I'm on your side, guys, but I'm telling you, this is what you have to do to get all of the points. You recopy the whole problem all over again, and yet you have to link that to the limit with the derivatives. So you do each limit separately, show that they're both 0. You can't do it together because 0 over 0 isn't a number. Okay, so you have to do them separately, and then you write the original problem and link it to the derivatives with your limit notation. So now we get to actually do the problem. What are the derivatives? This one would be 2x minus 4, and this one would be 2x plus 3. So it's a point for this first part, it's a point for linking these, and then it's a point for your answer. And do you guys know that sometimes you have to do L'Hopital's rule twice? Like if you do it again and you still get 0 over 0, you just do derivatives again. Okay, and you can just link them all together. What is this? Negative 2 over 5? Yeah. Verify. Okay, so 3 points. Not hard, it's just a lot of writing and you have to remember to do it. All right. Only if it's free response. All the rest of them, we're going to just do the problem. Okay. So for this one, if you plug in 0, do you get an indeterminate form? Yeah. Yes, because e to the 0 is 1, minus 1 is 0, and then 0. Okay, so this is going to be limit x goes to 0 of what? We're going to do our derivatives. So it's itself. And then what rule have we got? Yeah. Chain rule times 5. No, you got it all good. And then 1 is a constant, so that's gone. All right, denominator, derivative of just plain x is 1. That's why this rule works, is because every time you take a derivative, you go down a degree. So you kind of cycle down so you have nothing left. And I'm sorry, this just popped into my head, so I need to bring this up. Don't ever just do L'Hopital's rule without plugging in the number, because if it doesn't come out to one of these, you can't do this. Do you get what I'm saying? If it came out to like 7/0, what does that mean? Okay, good. Just checking. Just wanted to make sure. Go ahead.
You're planning to keep the L'Hopital's running until you get an answer?
As long as you keep getting one of these.
Okay.
Yes, as long as you keep getting one of these, you can keep doing it as many times as it takes. Yeah. I have one on here that does that. All right, so if you plug in 0, e to the 0, anything to the 0 power, 1 times 5 is 5, over 1 is still 5. All right, limit x goes to 0. I threw this on so I can see if anyone remembers your derivative of square root. You want to just memorize it. It's 1/2 square root. Now, it's square root of whatever. Yeah, like that stuff. Now, there would be a chain rule here. You would chain on the derivative of x plus 25, but that would just be, what is your derivative of x plus 25? It would just be 1. You're welcome to write times 1 if you want. I think that clutters it up, so I'm not going to do that. Right? And then this whole thing is over 1, which again, that's kind of the whole point, is it's like every time you do a derivative, it's going to cycle down. All right, now we're going to plug in 0. So what is that? 5 times 2 is 10, 1/10. Good deal.
Wait. 1/10
Let it marinate. It is 1/10 though. All right, last one of these. You cannot plug in infinity. That's not a thing because infinity is not a number. But just imagine the largest number that you possibly can. You're going to get infinity over infinity. Do you see what I'm saying there? Like if you need a visual, your LN graph looks like this. Do you see how it's going to keep going up forever and ever and ever and ever and ever? Like infinity. Okay. So we get infinity over infinity. And so we're going to do L'Hopital's rule. To still piggyback on your question now, the only way you can really end up with infinity over infinity is if your limit approaches infinity. It's kind of the only way that that can happen. All right, so derivative of ln 1/x, and then derivative of x is just 1. And again, we're not going to plug in infinity, but imagine the very largest number you can possibly imagine, like a trillion. If you have 1 trillionth, is 0. You're leveling off at 0. The analogy I always use is it's like a teardrop in the Pacific Ocean. Like it's so tiny as to be insignificant. Oh, I did put one more in here. For this one, you can only do L'Hopital's rule if you have a fraction. This is not a fraction. So the very first thing we're going to need to do is rewrite it. X would stay on the numerator. Why can I put e to the x in the denominator? Beautiful. You guys have good algebra on top of it. Right? I know, I'm trying to fix it. I really don't like this document camera, but we got to persevere. I have to keep my hand there to make it autofocus. So I keep on putting my hand in the picture. All right, you would get infinity over infinity, so we're going to do our derivatives. Derivative of x is 1, derivative of e to the x, plug in the largest number you can possibly imagine, and you're going to get 1 over a million, bajillion, gazillion, trillion, so 0. So again, to like wrap that up, if you have a limit going to infinity and you're doing L'Hopital's rule, and you lose your mind, a good guess for the answer is 0. Okay? Because if you have an enormous denominator, it's going to end up going to 0. Right? I'm going to show you the inverse. I can feel like we're fading, but this was the last thing I was going to show you. Can we rally? Are we good? Okay. So go back to your last little bubble. We did L'Hopital's rule, so we did the derivative. The derivative of x is 1. With e to the x, it looks like nothing happened because it's itself. So yeah, it looks like nothing happened, but we took a derivative. Right? Last little bubble. This is your inverse derivatives. Did you do these?
Yeah.
Okay. So I teach these with a table. To me, it's the easiest way to show it. So I want you to make a little table that has x, f, and f prime. And then we're going to make a little table that has the inverse, which the inverse means a little -1 in there. And then I hate this notation, but it's kind of the way it is. You're going to put inverse prime. So a little -1 and a prime mark. Sometimes they'll call the inverse G, and you can use a different letter. And sometimes they won't. Sometimes they'll just call it F inverse, and you have to put the little -1. So whatever, just go with it. It is the way it is. I'm gonna let you guys make these up. Can you give me some single-digit numbers? Single-digit numbers. 2. All right, this is 2, and I heard 5.
8.
I'm not there yet, but I will use 8. Whoever was really confident about 8. All right, if that is 2, 5, your inverse is 5, 2. That's the definition of an inverse. You're reversing the input and output. All right, now if f prime of 2 is 8, then your inverse derivative at 5 is 1/8. You reciprocate it. So the easiest way to do it is just to make some little tables and then kind of do a scavenger hunt and find everything that you're missing. But this would be the answer. I'm going to show you right now. I put a couple of examples on here. So here we go. So when you see this little -1 for inverse, immediately you want to just like set up your scavenger hunt. Set up your little tables for everything that we're going to find. And whatever lands right here is your answer. So to set it up blank, we're going to do a little scavenger hunt. And whatever lands where I circled, that's the answer to the problem. You can't find the derivative of the inverse because they don't give you the inverse. You can't take a derivative of something you don't have. Do you know what I'm saying? You can't work with lacking information. So you have to work with what they do give you. Now, what is going to go right here where I'm pointing? We want to find the derivative at 6. So 6 goes right there. That means in my other table, where can 6 go? F, because they reverse. That's the definition of an inverse. Now, that allows you to set up a problem. We can set this function equal to 6. So this is like the work we're going to do. We're going to do some algebra. So welcome back to Algebra 2. Make your Algebra 2 teacher proud. What would you need to do to start solving that? Yeah, I call this evacuate when I teach it. Evacuate, evacuate. Get everybody to one side so that it all equals 0. Evacuate, evacuate. And then the point is that you can factor. So make your Algebra 2 teacher proud. This is where you would have learned that, right? Let's all just take a minute and factor it and then go, I got this, what did you get? I love I got this, what did you get? So everybody just take a minute and do that. I'm going to take mine out of the screen. And I will tell you, you need to be really careful with your symbols on this one.
I got
them the other way around.
How did you get that? I got -3 and +2.
Did you write your 2x and your x in the other way around? That I did?
I put 2x in the
Oh, okay, then we're fine. You just wrote yours the other way around then.
Yes.
Is this what we're coming up with?
Yes. Yeah.
So the other way you could write it is x minus 2 and 2x plus 3, but you can't mix and match them. You can write these in the other order, but the symbols have to go where they are. Let me talk you through it. What do the outsides give you? If you have 2 times -2, that would be -4, and then plus 3. So -4 plus 3 gives you the -1 in the middle. So the symbols have to go like that. Anytime the last number is 6, it's always really hard because the 2s and 3s are weird, right? But two answers there. This one would be -3/2, and this one would be 2. One of them is right, and one of them we're going to get rid of. Look back at the problem. It says x needs to be what? Greater than 0. So we want x equals 2, which I'm sure you're all really happy about because we don't want to deal with the fraction. I'm handing it to get it to. Come on. There we go. So if that's 2, where else can I put a 2? F inverse. Okay. Phew, we had to work hard for that. We had to do algebra. All right, now we're going to find f prime. I'm going to write it up here so that it's right next to the function. What is your derivative of that? That's going to be the easiest part of the problem. 4x. Perfect. And here's the $1 million question. Do you plug in the 2 or do you plug in the 6? Look where I'm pointing. 2. You plug in the 2. Do you see that? Okay. If you plug in 2, you're going to get 7. And so your answer is 1/7. That's your answer. We're just going to try one more. I know, and I hate when there's a negative. And here, you know what? We'll do this one different. I will give you my paper when we're done. Okay. Okay. So for this one, can we call the inverse G? I'm going to name it G. Is that okay with everybody? But if you want to write inverse, you can. But I don't like that either. The inverse and the prime. It's like a -1 and a prime. I don't like that. But oftentimes they'll give it a name. They'll call it G or H or something else. So let's set up our scavenger hunt. This will be our answer, whatever lands there. Where can I put this 4? X on which one? The right one. The inverse one. I'm calling G the inverse. Perfect. Before I could even say it. Now that allows you to set up a problem. You're going to set this function equal to 4. Here's what I would do. Guess and check. Because 4 is a little number, and I'm guessing, I didn't even really look at it. I'm guessing if you plug in 1 or 2, that's the answer. Guess and check is a totally valid way to get through something. I would try plugging in 1 and see if it works. Try plugging in 2 and see if it works. It's 2. Can we mentally do that? Is it 2? Yeah, really. 2 squared is 4. 2 minus 1. Perfect. So 2. Wasn't that a lot quicker than anything else we could have done? Totally valid way to get through a problem. All right. Where else does 2 go? And G. Perfect. Now we can do a derivative. What rule do we need? Perfect. Everybody just go ahead and do that. I think we're at the point where I can allow that. And then do I got this, what did you get? Or you can just look at mine and make sure that we're all doing the same thing. Our timing is going to be perfect today. It's going to be exactly what I wanted. All right, I got that. What did you get? Perfect. All right. $1 million question. Are we going to plug in the 2 or are we going to plug in the 4? 2. Perfect. That's the thing I usually get people mixed up on. And you know, in multiple choice, one of the wrong answers will be if you plugged in the 4. Okay. So if we plug in 2, oh gosh, we're going to have to fight through this. 2 times 1, or sorry, 2 times. 2 minus 1 is 1. 2 times 2, 4, minus, what would that be, 4? Yeah. Over 1 squared. That all shakes out to 0. So let's have a quick conversation. If that is 0, and use brain, then speak words, okay? If that is 0, yes, undefined. Very good job. Undefined is what kind of a line? Very straight. So by definition, all lines are straight. Vertical. Undefined slope for a vertical line. Yep. Saying straight line is like saying ATM machine. Do you know what I'm saying? Like all lines are straight. Yeah.